So, good morning everyone, and my name is Umang Goswami. I work as an educator on Unacademy, and you can follow my courses here. And today's lesson will be on the topic of absorption under mass transfer in the chemical engineering discipline. So, please do share these videos and download the Unacademy Learning app, and also subscribe to the YouTube channel of Unacademy. Thank you. So good morning everyone, and welcome to lesson number 43 of mass transfer in the chemical engineering discipline. So in the last lecture we discussed about last couple of lectures we discussed about material balances. Firstly we discussed about absorption, in that co-current absorption, counter-current mode. Then we discussed about stripping, co-current and counter-current. We said that for the counter-current operation, the region of the driving force or the shaded area which we observed in the graphs will be more, that is the region of driving force will be more, and that is why in industries you might have seen that mostly counter-current operation mode is used when compared to the co-current mode. Similarly, we also discussed about the solid free bases, that is LS, GS, capital X1, capital X2, capital Y1, Y2, and I also said that whether you are taking co-current mode, counter-current mode, always remember the input streams from where they are entering. If they are entering from the same side, it is co-current mode. Entering from the different side, it is known as counter-current mode. Similarly, for stripping also, co-current and counter-current will work in the same function, but there will be some changes. Now, for stripping, we derived the formula, that is LS by GS value. You can refer to the previous lecture, and for counter-current mode also we discussed in the same manner. Now this is known as the equilibrium curve. Okay, so this curve is known as the equilibrium curve, and this will be obtained from the thermodynamic data. Now for absorption, we plotted the graph and it was like this for co-current mode, and for counter-current mode it was like this. Similarly, for stripping also it will be in the same manner, but the only difference is here the operating line will always lie below the equilibrium curve. Remember one thing, for absorption it will always lie above the equilibrium curve, and for stripping it will always lie below the equilibrium curve. We can develop a short trick to remember. Now for absorption we have AB, and for above we also have AB. So for absorption, operating line above the equilibrium curve, and we know that in stripping, now we have already studied distillation, so the bottom section was known as the stripping section. So here the bottom section is known as the stripping section, and here only the operating line will lie, that is below the equilibrium curve. Okay, so always remember in GATE examination or in other examination you can always expect a question from this. So now let us discuss some more terms which are known as stages, cascade, and we'll discuss about it. So stage, it is an equipment in which two insoluble phases are brought into ultimate contact where mass transfer occurs between the phase to bring the condition of equilibrium. Okay, so the mass transfer is taking place between different phases and the condition of equilibrium is achieved. So we have a stage here, like the entering is from the liquid enters from here, that is LSX1, and the gas enters from this side, GSY2, and this here it is GSY1, here it is LSX2. So what we can say, stage, it is an equipment in which two insoluble phases, that is L and G, are brought into ultimate contact. So here they will first come into contact where mass transfer occurs, that means the transfer of solute either from the gaseous phase to the liquid phase or liquid phase to the gaseous phase will take place, and ultimately bringing the condition of equilibrium, because we know that beyond equilibrium beyond the equilibrium point we cannot separate it out. Only till equilibrium value only the transfer of solute will take place. Okay, so now this is the case, and always remember that leaving streams are in equilibrium. That means whatever the streams are leaving from a particular stage will be always in equilibrium. Now what are the streams that are leaving? The streams that are leaving are LSX2 and GSY1, because x1 and y2 are the entering streams. The leaving streams are y1 and x2. Now always remember that from Henry's law you will have a data like y is equals to mx. Now when you have y is equals to mx, that means you can directly apply it for the leaving streams. That means it will become y1 is equals to mx2 and whatever it may be, because the leaving streams must be in equilibrium. That means the equilibrium data is applicable for the leaving streams. And always remember one thing, that whenever in the question it is asked to find the minimum flow rate of the solvent, always remember that then in that case these streams will be in equilibrium. Okay, we'll discuss more on that, but as of now always remember that in that case where you are asked minimum solvent required, then these streams will be in equilibrium. Now how we decide stage efficiency? Now we know that efficiency is always actual mass transfer upon ideal mass transfer, or actual heat transfer upon ideal heat transfer. Okay, so ideal heat transfer. Now ideal heat transfer, let's understand how it goes. So this is the case. Now equilibrium line, okay, and this is the operating line. Operating line is lying above the equilibrium curve, so it will be an absorption operation. Similarly, we can say that absorption operation, and that to a co-current mode. Okay, so this point is y1 and this point is y2, and on the equilibrium curve we will have another point which is known as y star, or the equilibrium composition. So corresponding to y star we have x star, y1 we have x1, y2 we have x2. Now efficiency is actual mass transfer upon ideal mass transfer. Always remember this is applicable everywhere. So actual mass transfer is y1 minus y2, because we are going only till y2, and how much you can extract or how much you can transfer will be capital Y1 minus capital Y star. So this is y1 minus y star. Okay, so this is the concept of efficiency. Now when we talk about cascade, so cascade is basically series of stages. Okay, so you can observe here that a series of stages is kept, and then the operation is being carried out. So here the inlet stream is LSX1, and we are considering that stripping operation is taking place. So LSX1, and this is GSY0. Now remember that Y0 is that for all the stages we will have the entering stream as GSY0, GSY0 and GSY0. Okay, I forgot to keep it here, but you can draw it or you can write it. So this becomes, here it will be GSY1, LSX2, GSY2, LSX3 and so on. Now you can get this idea. Now since it is in stripping operation, therefore x1 will be greater than x2 will be greater than x3, and similarly capital Y1 will be greater than capital Y2 will be greater than capital Y3. Okay, now let us apply the balance. So on stage 1 the inlet streams are LSX1 plus GSY0. So LSX1 plus GSY0 will give us GSY1 plus LSX2. So this gives us GSY1 plus LSX2, and when you rearrange it, it becomes LS by GS is equals to Y1 minus Y0 upon X1 minus X2. Similarly on stage 2 when you apply the balance, so this will be LSX2 is entering, GSY0 is entering, the leaving streams are Y2 and X3. Now we know that in whenever we consider it as a stage, so the leaving streams are in equilibrium. So therefore there will be an equilibrium relation between Y and X. Here also equilibrium relation between Y and X, and here also Y and X. Okay, so on stage 2 this will be the expression, and on stage 3 this will be the expression. Now why I am telling you this, because in examination you will always find questions on find the number of stages, or if there are 2 stages, what will be the exact composition of the liquid phase or the gaseous phase. So from that point of view, these balances are very important. Now let us come to another term which is known as absorption factor. Now absorption factor is denoted by capital A, and it is given as slope of operating line upon slope of equilibrium line or equilibrium curve. Now we know that, now suppose we have equilibrium curve as y is equals to mx. So the slope of equilibrium curve will be shown by small m, and slope of operating line. Now we have already seen that slope of operating line is L by G. Okay, we have already discussed that slope of operating line is L by G. Slope of operating line, slope of equilibrium line is small m. So therefore, capital A will be equal to L by mg. Okay, and stripping factor, which is known as capital, which is denoted by capital S, is equals to 1 by capital A. And now since it is the reciprocal of it, so this becomes slope of equilibrium curve upon slope of operating line. So capital S will be equal to mg upon L. Now remember, always remember that A is equals to L by mg, stripping factor is equals to 1 by A, and capital A is equals to slope of operating line upon slope of equilibrium line. This is the basic of absorption, and it will be very helpful to solve the numericals, and do practice all these concepts. And from the next lecture we will be dealing with the core absorption part, height of tower and all. So till then, thank you.